Good morning, class. Today we're going to talk about polygons. And from our previous lessons, we've talked about triangles and quadrilaterals already. Do you remember what a polygon stands for?
I think something about lots of sides.
Okay, poly means many sides. So it's a many-sided figure. There we go. So those are polygons. We've already learned about some types of polygons called triangles and quadrilaterals. We've also, in the previous lesson, worked through the formula for an area of a triangle and for the quadrilateral. What I want you to do with this lesson, however, is take the worksheet in front of you and fill in the information as I go through it, and then at the end of the lesson we are going to compare notes and you're going to get a worksheet. Alright, so can you tell me what the area formula for the area of a triangle is?
Half base times height.
Excellent. So half base times height. And what we're referring to here is this length is our base. Okay. And the perpendicular, there's a right angle triangle there, a right angle. That height is our height. So that's the height and this is the base. And that's our formula for the area of a triangle. Do you remember what the formula for the area of a rectangle is?
Length times breadth.
Excellent. Okay. Mel is referring to the length being that guy and the breadth being that length. So I'm going to write it as base times height. Here, that is the base, and that is the height. Do you agree with me that that is the same as length times width?
Yes, sir.
Okay. What if we took this idea and we took it to other polygons? What I want to show you is, remember in the last lesson, what we did is we affirmed, or we proved to ourselves that these formulas are right, in that we could take this rectangle and divide it into two triangles. And I hope you can agree with me that the area of a rectangle is just twice the area of a triangle. So what if we took that idea and we took it to all polygons, all multi-sided figure? I know the formula for a triangle is, we've just had it, is half base times height. So that's the base times height. What if I divided this polygon into triangles? So I make a triangle there, I make a triangle there, I make a triangle there, triangle there, and a triangle there. Alright. And now I just need to work out the heights of those triangles, and off I go. And if I get the area of this particular triangle, I just add it to that triangle, etc., etc. That sounds like a good plan to me. I hope that you can see that there's a bit of a problem with that idea though. It seems very tricky for us to find the length of that base, and then even harder to find that perpendicular height. It can be done, but it's not so easy. What if we first of all concentrate on regular polygons? So, regular polygons, do you remember what some of the characteristics of regular polygons?
They've got the same length sides and this, something about their angles are equal.
Okay, so what Mel is saying, that they've got the same length sides. Excuse my pen. So we mark the sides, and that's the mathematical notation for the sides being the same length. All right, and we can call it equilateral. You can fill that into your sheet. Okay, same length side. Right. Also, as Mel said, the angles are the same. And that's how we mark the internal angles of the polygon being the same. So they are equiangular. Same angles. All right? Everybody happy with that?
Mm-hmm.
Okay. One thing I haven't told you about regular polygons, and I've drawn another regular polygon here, is that it can be circumscribed by a circle. All right? So what that means is this polygon fits neatly into a circle. So each of the corners or vertices touch the circle. Remember, it's a regular polygon, so all the sides lengths are the same. And this particular polygon, it has got 1, 2, 3, 4, 5, 6, 7, 8 sides. The thing that we know about circles is that it's got a center. Can you see I've marked the center? Right? And we also know that I can draw a line from the center to the outside, the perimeter of the circle, like this. Okay? And that is a radius. What happens if I connect each of these points with the center of the circle? Would you agree with me that each of those lines are the same length? Because they are the radius of a circle. So that one's the same length as that, is the same length as that, is the same length as that, etc., etc. All right. Has anybody counted how many triangles we've got? We've got 1, 2, 3, 4, 5, 6, 7, 8. That's no surprise. We've got the same number of triangles as the number of sides. And these triangles are isosceles triangles. So what happens if I can work out the area of one of these triangles? These triangles, as we've said, they are isosceles, but all sides are equal, so each triangle is congruent to the next. So if I can find the area of one of the triangles, I just multiply it by the number of triangles. What we do need is the height of these triangles. So I'm going to use the green to show you. That is the apothem, and it's a definition of a perpendicular height which comes from the base to the center of the circle. All right. That's a bit tricky to see. Okay, so what I have here is I've got the formula for my one triangle, okay, is half base times height. But the formula for working out the area of of the whole polygon would be the number of triangles, okay, the number of sides of the polygon. So it's the number, the base. What we can actually call that is the side length. Okay. This guy here, which we've defined as the apothem, and divide by 2. So it's exactly that, just with a number of sides. Alright, what I want you to do now is fill that into your sheets, and then we can do a problem hunt after that. Alright, off you go.